exercise 61. So prove that for a local field with characteristic P, there is this infinitely many separable extension of K of degree P. So actually proof to show that there exists infinitely many such, there is a group of such kind of extensions, so given by the Artin-Schreier extensions. What I want to prove is to prove that there exists infinitely many. So what is Artin-Schreier extensions? So firstly, recall that this is more general than our situation. K be characteristic P field let small a be any element of this field K. Let L over K the extension with alpha a root of the equation of the form x to the power p minus x equals a. Then L over K is Galois with Galois group so actually this is a fact. Okay, in particular this is telling that any polynomial of the form is irreducible. Okay, so this is enough for our purpose. Just consider extensions of k given by x to the power p minus x minus a with a in k, then is a degree p extension more, as we remarked. This has actually got a lot of degree p extension. So actually, you could call this as a fact or exercise. Okay. Degree p extension separable. This is obvious because fx derivative is not zero. So this is a separable polynomial. It's a degree p extension because this is a reducible polynomial, so it gives field extension of degree p. And notice that if you choose different a, gives you different field extension, of course, because corresponding field extension contains roots of this polynomial, and so for different a gives you roots of different polynomial, and so the field containing those different containing roots of different polynomials then not the same. So what is left to show is that why are there infinite many, because this is in our assumption local fields of characteristic p, so local fields of characteristic p is always of the form fp representation, some finite field small k and then double parenthesis of uniform of some transcendental element if you want, and this will become the uniformizer of this local field. So there are infinitely many elements. I say that. So it's infinitely many. It gives infinitely many separable extension of degree p. So I'm left with a question: are there infinitely many inseparable extension of k of degree p? So the idea is consider fx equals x to the power p minus a with some a element of k such that is not some p power, otherwise this is just x minus b parenthesis to the power p, right? This will imply that x minus does not give you a field extension. This is not a degree p field extension. Okay, when a is not p power, can you show or is x to the power p minus a irreducible? I mean, obviously this is inseparable, as its derivative is 0, right? So if it's reducible, then it gives you degree p inseparable extension. And again, if you have infinite many a which is not p power, this should be the case in local field characteristic p, because again the transcendental element pi, a uniformizer, its powers, there are infinitely many power of it, that's not p power. So the only problem is this irreducible? So left you to think about this. So finally, let me mention a lemma. So this is the converse of the fact mentioned at the beginning. So that fact together with this lemma, you could call it Artin-Schreier theory. So I'll give it a name. Artin-Schreier extension. Let L over K be a Galois extension. Of fields of characteristic P, not requiring local fields, just characteristic P, with Galois group. Cyclic group of degree P. Then we claim it must be of the form like the Artin-Schreier extension, then L is isomorphic to k-adic some element Z with to the power p minus z in k. In other words, there is a root of Artin-Schreier polynomial.